Hello everyone, so welcome to the class for Geography Optionals. So here we are discussing the Geography Optional syllabus and the book list that is required, and we are trying to decode the Geography Optional because the syllabus is very vast. So let's see how we will be handling these questions, how we'll be taking care of the Geography Option classes. So first of all, the discussion is about syllabus, what are the different components that are expected to study, and what are the sources of these various discussion or various topics of the syllabus. And here in this discussion, the focus would remain on the topics which we should pay more attention and which are very essential for your exam, and trying to understand what is required to understand these topics, right, with the reference books. So when we talk about Geography Optional, a lot of people have asked me what is the success rate of Geography Optional. In one of my discussion, I've already given the percentage of the success rate of Geography Optional, and I've maintained this, and I'm repeating the same point, that it is not the optional which get through, or it is not optionals which score. It's the students who score in that particular optional, and given the interest in the subject, proper guidance, and your comfort level in writing answers will determine your score in optionals. So here we are going to have discussion on the detailed discussion on every component of Geography Optional. What is required for the optional? How should we be handling this? And I must tell you about the optional as such. See, in classes we would try to give you conceptual understanding of the topic, required information, factual informations. In topics which are very applied and very dynamic, right, we will be also giving you discussions about current affairs and also helping you with some handouts. But there is this discussion, a lot of people ask this question again, is geography a static syllabus or is it dynamic? And what should we do to study static and what should we do to study dynamic portions? Friends, I'll tell you one thing very honestly. See, nothing is static. Nothing is static. And the dynamic portion does not exist without the static portion. What do we mean by that? See, if you study what are static portions? Right? They say static optional or static topics. Like, suppose I take an example of plate tectonics. I take an example of, say, cyclones or ocean currents, or the physiography of India, like say paper 2, or for that matter some population theories. Now these are considered to be static portions. But it is implicit, it goes without saying that if you are studying the static portion, suppose plate tectonics, and there is volcanism somewhere, volcanic eruption has taken place somewhere, and it has caused some significant effect on the flora fauna population, obviously you will take a note of that and incorporate in your answers, in your notes, when about the volcanism, the recent volcanic eruptions. Obviously that goes without saying. Any topic, any student of geography or any optional for that matter will add information to call as static. So it is, suppose, let me take another example. Suppose there is a theory which was given in like 1960s or 1860s or 1700, like Malthus. Do you think Malthus Malthusian theory is a static theory? The application of Malthusian theory can be seen in many other countries of the world. Till date we give reference to Malthus. So it is not a static, it all depends upon how do you interpret the theory. If you consider these topics as static topics, I'm afraid you do not know how to relate topics. You do not know what the interrelation. So those people who are considering a static portion as a static portion, don't think like that. There is dynamism involved in every topic. That is why it becomes a part of syllabus. Otherwise it would have been a part of research. And if there is a research going on, obviously things will change. There will be additions, there will be criticisms, there will be, support to some theory. So even theories are not static. You need to know, you need to rather get this understanding how to relate these theories in contemporary times. Suppose, another example, we talk about the ocean currents. So there is a set pattern of ocean currents, how we study ocean currents. We study the factors affecting ocean currents, we study various types of ocean currents, cold ocean currents, warm ocean currents, and so on. But there have been changes over the period of time in the ocean pattern of ocean currents. There are contemporary aspects to it, like North Atlantic meridional overturning circulation, which was discussed 2019 newspapers. If you read newspapers, 2019 newspapers, it was discussed that it is bringing a significant change in the climatic condition of Europe and India. When we study jet stream, it's a static portion. Read your articles few days back in Indian Express, that it said that, in not only Indian Express, it was in the Hindu and other newspapers as well, that North Atlantic air jet is causing, rather it caused a slump in Indian monsoon in 2020. So how do you interrelate? You understand the basic concepts, you understand the crux, you visualize a phenomena, you visualize a concept, and afterwards you start relating to the contemporary aspect, you start relating to the happenings around you. And that is where the question is coming from. That is where the topic is asked in exam. A lot of people ask me, how should we prepare current, and especially the first timers, especially the freshers, those who are just the college pass outs or they come out of their masters from universities, those who start preparing and spend just 1 month in preparation. They ask how to prepare current affairs. I tell them, see, current affairs is important, no doubt about it. Let us first understand how does the functioning happens. Let us first grab the concept, and then you can do the icing on the cake. But first let us make the cake. Let us understand the procedure. Let's understand how things function, and then you come to the come to the information, come to the level where you can understand how things are functioning now. Like, if we do not understand the basic concepts of economies like repo rates and CRRs and so many other concepts, how can we understand why RBI has increased or decreased CRR or SLR or whatever rates? So economy page becomes redundant for us. We do not understand the economy page of the newspapers. We do not know what was lookist policy. How do we understand the actist policy? How do we understand what is the look west policy? What is the significance of look west policy? If we do not understand why Persian Gulf has so many resources and what are the resources that we find in Persian Gulf, we won't understand why Strait of Hormuz becomes so important for us. Why is it being discussed? So before starting the syllabus, this is my serious suggestion to all of you. Let us first understand the concept. Let us first understand how things work, and then we can garnish our studies with current affairs, and then you will be able to relate why is it happening. Alright, so let us not consider any static portion. Like, let's understand a topic as it is, let's observe the topic as it is, let's observe the concept as they are, And then we will see, what is happening in the present context related to that particular concept. That is how you should be able to integrate and interrelate your preparations. So then your thought process will probably ignite. Otherwise, what happens is we read what is happening around the world. We do not focus why is it happening around the world. What are the basic reasons for that? How things have happened in the past. So without a background, without the basis, current affairs will be just an information. You will not enjoy, you will not be able to relate. Right? That is our main theme, that is our main focus, especially in the classes for geography. We will be interconnecting the static portions with the dynamic portions as well. I mean, so-called static and dynamic portions as well. So let's start with the optionals syllabus one by one. Let me first tell you, this is the first topic of your paper 1. What is it? It is geomorphology, right? It is the geomorphology part. And in geomorphology, these are the topics. What are those topics? Factors controlling landforms, endogenetic and exogenetic forces. Then we have origin and evolution of Earth's crust, fundamentals of geomagnetism, physical conditions of Earth's interior, geosynclines, plate tectonics, recent views on mountain building, and so on. Okay, now let's see what is required for geomorphology. See, this particular topic will deal with the study of lithosphere primarily, right? It deals with the study of lithosphere. When I say study of lithosphere, it means the features that we see on the surface of Earth. And what do we see on the surface of Earth? We see mountains, we see volcanoes, we see rift valleys, we see earthquakes taking place on the surface of Earth. We see various landforms like glacier, like wind, like fluvial landforms. So we need to focus upon lithosphere. We need to focus upon features that we see, physical features that we see around us. This particular topic was previously referred as the physiography. Right? Physiography. What do we mean by physiography? It means description of the physical features. Graphy means to describe. Physiography, that means physical features. The description of physical feature was called as physiography. So from Greeks, Romans, Arabs, Indian geographers, including other geographers of like Russia, like they focused upon description of the features that they observed around them. But with the advent of technology, with the advent of scientific concepts and so on, right, there was a growth of this subject called as geology, which seeked the explanation of these features. Like we started trying to explain how mountain building happens. We try to explain what is the cause for volcanism. We try to explain what is the cause for earthquake. What are the different types of rocks and why and how they are formed. So with the introduction of why and how, it becomes geomorphology, where we focus upon the description along with the explanation of features around us. Right? I'm repeating this, that physiography gives an idea about what, where, right, when, and here we try to explain why and how. Isn't there? There are basic questions. There are 5 basic questions for any to learn any topic. What is it? Where is it? When was it? Or when is it? And then how and why. So when you have this kind of complete understanding, right, you will be able to handle the questions in exam. So break up your topics in these 5 questions, right? This is the aspect. So this is what we study in geomorphology, right? And so far as the exam is concerned, if you look at the previous year trend, right, if I go before 2010 or even till 2005 or before 2005, the main focus was topics like, these evolution of Earth's crust. Focus was on plate tectonics, right? It's not that these topics are not asked now. Of course they will be asked, they can be asked now also. After 2009-10, if you look at the question paper, the change in the trend of question paper, because there was an addition of the syllabus, new syllabus was added, you will find the focus is more on these topics: channel morphology, slope development, right? Slope development, applied geomorphology. So these topics have become very, very essential so far as the exam is concerned. And there is one topic which is not mentioned in the syllabus of the UPSC, geography options, and these are geomorphic principles, right? Geomorphic principles. Now I must tell you this point, that geomorphic principles are quite, they're not easy to understand. We need to have complete understanding of geomorphology, right? Especially the landforms, in order to understand these 8 principles of Thornbury, which was mentioned in a very philosophical way. To understand the philosophy of the subject of any topic, you need to have that in-depth understanding, right? And then you can develop that analytical skill to understand. So this is the main focus. But can we ignore these topics? Factors controlling landform, endogenic, exogenic? No, the entire syllabus is based on endogenic and exogenic forces. The first part of the syllabus is about endogenetic forces, right, where we focus on the physical conditions, and then we focus on plate tectonics, we focus on formation of mountains, earthquakes, volcanoes, and then exogenetic forces. It's like endogenetic forces form something like mountains, plateaus, or whatever, and exogenetic forces sculptures them, right? As the sculpturing is done, like the chiseling is done, and they create different types of forms. Exactly in the same way, different types of forms are created by various landforms, various agents. Like a river will carry V-shaped valley, right? When river distance from these mountains, it will cause vertical erosion and then can form V-shaped valleys. But can we find V-shaped valleys in desert landforms? No, there is no river, active river as such. Can we find V-shaped valleys in glacial landforms? No. When the ice rolls down, it will be much wider valleys, like glacial troughs can be formed, not V-shaped valleys. So there is an interconnection of climatic conditions as well as geomorphology here. As we find in a very heavy rain regions, like suppose in the regions where rainfall is very, very high, what will happen? Suppose we're talking about the place like Jharkhand, or we're talking about the place like Equator, where the rainfall is very high compared to other regions. So rainfall will have overall erosion on a mountain, right? It will not cut it from one particular side. It will have impact on all sides. So generally you will find these rounded hill-like structures as the end product of erosion, which was called as monad-Knox by Davis. But if I'm talking about a feature which is like glacier, and it does not have equal impact on every side of the mountain, rather it erodes one part of the mountain more than the other. So you have these sharp edge-like features, erites. At the same way, if we talk about the wind has the horizontal impact more than the vertical impact. So what we are going to see are these table-like features, right? Because even the top of the mountain can get eroded. So we have these table-like features called as mesas or buttes. Right, so this is how you try to relate concepts. This is how you try to put your answers. This is just a brief idea how things will work, how things will be discussed. And one important element of your UPSC preparation is not how much do you know, right? That goes again without saying, implicit, that you should have information. But what is the most important part of your preparation is the application. So we also have this applied geomorphology. So you know about rocks, you know about the pattern of rock formation, you know about various landforms. So what? You know how earthquake is taking place. Then how is it useful for the society? How are you going to put your information for the society? That is where you need to emphasize, and that is why we have these very important topics of applied geomorphology. And expect questions from these. Right? The pattern of question has significantly changed towards more applied aspect, in-depth analysis of all the topics. Right? So let's come to the next aspect. For geomorphology, if we talk about the book list for geomorphology, there are so many sources available. Obviously, we will provide you the material. There's so much of material available in the market, on the internet, and so on. These days, limiting yourself is very important, right? Because you have so much of material that it gets very difficult to digest at times. We will try to give you the simplest and shortest possible, so that you can think on your own and develop and produce your own thoughts. First would be, obviously, there is this book. Nobody can forget this book, and that is Physical Geography by Savindra Singh. Physical Geography by Savindra Singh, right? Or you can also refer to Physical Geography by D.R. Khuller. They have almost of the same syllabus, same aspect. See, Savindra Singh, the Physical Geography by Savindra Singh, when you take this book, the entire physical geography is mentioned in that particular book. Their topics, when you start the book, then there's about the description about geography and how geography has evolved over a period of time. Then there's origin of Earth, and then there are other topics like isostasy, and then it starts with geomorphology topics. You can go topic by topic looking at the syllabus. So you should have a copy of syllabus and tick mark the topics which are to be discussed from this, which are to be studied from the particular book. While reading Savindra Singh book, there are a lot of references made to the other books. So don't worry about these books which are referred in Savindra Singh. Some people say, or they think that okay, this book should be good, this book also. So they order so many books, they get collection of so many books which are not required. Physical Geography by Savindra Singh would be very handy, very useful. One more thing that you will be focusing here is the diagrams. So you will also copy down some diagrams from the book. It's a very relevant book. So please take this book. For geomorphology specifically, there are two references which are made. I'm just making first one. One is Geomorphology by P. Dayal. There is another book, Geomorphology by Savindra Singh. Let me tell you the difference between these two. See, Geomorphology by Savindra Singh is very handy. There's a lot of information in there. A lot of information is mentioned. So it gets a bit difficult for a student to actually concise that book, to actually study every part of it. We will be helping you by providing some selected portions from that particular book, so that you don't have to worry about these detailed aspects We will be making a concise notes for from the particular book, giving the reference of the book, and will provide it to you. P. Dayal, see, it may not have the, a very expressive diagrams, maps, but the language is brilliant, like one of the best books so far as the language is concerned, and you will develop a very good understanding of this book, understanding of geomorphology from this book, P. Dayal, Geomorphology by P. Dayal. And the topics that you should be focusing upon will be topics that I have mentioned, like these topics are not mentioned there, like denudation chronology is not mentioned in physical geography by Savindra Singh. From this topic to applied geomorphology, you should focus upon P. Dayal. And rest these topics you will very well find in the Savindra Singh book, the physical geography by Savindra Singh. Right? These are the reference book. Now, rest is all up to you. You can also refer to some other books. I won't say no to books, but then read only the books which you can digest, right? Which you can actually comprehend. So these are the topics that you should be focusing upon. Topics like denudation chronology, topics like channel morphology, topics like slope development, applied geomorphology. These topics should be discussed from the Savindra Singh. Rest you can refer to the physical geography by Savindra Singh. But I'll repeat this point here. All this after going through your 11th standard NCERT. Right? The roadmap is like this. You make sure that you have gone through NCERT properly and then refer to these books. I'm not asking you to stay at NCERT only. For general studies, 11th standard NCERT, if you can understand between the lines, it's very good, very useful, fine. But for optionals, that is why I suggest to all of you, before you start the optionals, be thorough with this book, 11th standard NCERT, Fundamentals of Physical Geography, or old NCERT, Principles of Physical Geography. Then you can refer to these books. You can easily understand this book. Right? Okay, let's move on to the next particular discussion. And next topic comes as the climatology. Right? Climatology. What includes in climatology and what are the topics that we should mention? See, if the first topic, that is geomorphology, is about the study of lithosphere or description about lithosphere, it is about atmosphere. Right? Atmosphere. The features, the phenomena that take place in atmosphere are to be discussed in climatology. Again, when we refer to this particular topic, climatology, topics like atmosphere, temperature, pressure belts, heat budget, all these topics are important, which are also important for your general studies. Right? Where does optional and GS syllabus differ? See, till here you will study it in GS as well. Planetary winds, local winds, air masses. There was a question on air mass, cyclones, temperate cyclones. From here things will change. This Köppen's classification, Thorndike classification of world climate, Trivarta classification is not required for your general studies. It is an optional specific topic. Right? Then hydrological cycle, both GS as well as optional, it is important. And then global climatic changes. Right? Here in this particular topic of global climatic changes, basically we are talking about the climate change. But the theoretical aspect of climate change, that is, what are the different theories that suggest the climate change phenomena, because it's not a new phenomenon. It has been going on since probably the origin of Earth, Permo-Carboniferous period, then it was in Cretaceous period, then it was in Pleistocene age. There were these three major ice ages that we have witnessed, or that Earth has witnessed, and then how this deglaciation, how is this process going on? Theoretical aspect, considering the geological time scale, will be important for your optionals. Whereas for general studies, we just try to understand what is a climate change, and after that we talk about the recent events, like we start with probably with the Earth Summit, and then Kyoto Protocols, and then Copenhagen Summits, and then other summits, conference of party meets, and so on. We continue with that. But here it will be more of the theoretical explanation of climate change, what is climate change and how this urban climate is undergoing a change. Okay, so GS plus optionals. From here, if we start till the precipitation, it's all GS as well as optionals. After that, these are optional specific topics, and these are mainly for general studies plus options together. Very conceptual topic, and I must tell you, the science students, science background students, they enjoy it a lot. Sometimes, the concepts are simple, like pressure, temperature, how do they vary, what are the basic aspects. But it doesn't mean that students who are from humanity sciences or humanity backgrounds, they do not understand. Of course, they will also understand. It's not a rocket science. The relation between temperature and pressure and other things we have studied in school days, and here we are not applying these gaseous laws or any equations. Simple common man understanding of how temperature and pressure will change or affect each other, right? So we need to develop these concepts, and let me tell you, this is very enjoyable because it's full of concepts, it's full of understanding. We need to visualize geography, we need to visualize concepts and apply it. That is what is required for this. And comfortable, I've seen a lot of people comfortable in climatology. It will not trouble you, and the questions are also straightforward. You can easily handle questions in exam, provided your conceptual clarity is good. And then comes one more aspect, what is called as applied climatology, right? The effect of climate change on various aspects of the world, including urban climate, whether it's agriculture, whether it's geopolitics, whether it's social aspect. Every aspect it is having an influence. And I'll repeat the point again, that it is about how do you relate your information to the world, right? To your things happening around you. That is what is required, right? So applied climatology also becomes important for your exam. Questions have been asked. There is no particular trend that we can follow in this topic, right? Questions are asked equally from all the topics, so easy to comprehend. Then comes to the next aspect of this. Okay, let me come to the books for climatology. For climatology, again, 11th standard NCERT should be the first step. The second step, right, same physical geography by Savindra Singh. Physical geography by Savindra Singh. It will cover a lot of topics. In fact, all topics except for the climate change and Trivartha's classification. There is, you can get it from our notes as well, from the class notes as well as from the referred material to you. For your reading, see, a lot of people have started reading Critchfield. Experimental climatology. If they have so much of time, they can. Of course, they should. A lot of people started reading, the foreign author books, and there is some attraction towards these books in India because they're foreign author, and that will be there always. Anyways, so if you have time, if you have ample time, please read that books. There's no problem. For reference book, for reference to the climatology, if there's one simple book, that is by Climatology by D.S. Lal, which suffices the need for everything. I don't want you to take this book D.S. Lal, it is just for your benefit. If you have a lot of time, you can take this book. Otherwise, you have so many lists. There's a list of books on climatology. But this book, like Physical Geography by Savindra Singh, along with the notes, should be good enough. So I would always rather recommend Physical Geography by Savindra Singh plus notes should be good enough, but it's all up to your choice. It's up to you. Right? How do you take up this topic, and all up to you. It is not something like I would say that you should buy, I should not buy. But so far as Geomorphology by PTL is concerned, you should take that book. Right? Let me come to the next topic then. The next topic that we have is Oceanography. Right? Now the topic has few topics. This Oceanography has a reference from Geomorphology, some topics of Geomorphology. Also, it requires an understanding of the climate. So it's better to study Oceanography after Geomorphology and Climatology. Some people start with the Oceanography also, provided if they have a base in Climatology. Okay, very good, they can start with that also. But my suggestion would be, after completing these two topics, Geomorphology and Climatology, then only you can start with the Oceanography. And some of them can also start with Climatology. It depends upon the interest. See, you should always start the topic which you feel that is interesting, so that you gradually start developing interest in the other topics as well. That is how you get attracted to the subject. Otherwise, it becomes very boring. I mean, it's very difficult to relate ourselves to the topic if we are not interested in that. So after completion of these two topics, here we are talking about hydrology. So after lithosphere and atmosphere, it's basically hydrosphere. It's basically about hydrosphere. See, bottom topography of Atlantic, Indian and Pacific Ocean. That is why I said you should have a fair bit idea about geomorphology. You should be clear with the geomorphology concepts. Why? It's about the topography of oceans, Atlantic, Pacific, Indian Ocean. Now, in Atlantic Ocean, there is this mid-Atlantic ridge. I'm sure all of you, those who have studied in general studies, will know what is mid-oceanic ridge. Then there are features like seamounts, guyards, islands, basins, trenches. The formation of these can be understood if you are clear with the concept of plate movement. You understand plate tectonics, you understand faulting, you will understand trenches. You understand volcanism, you will understand mid-oceanic ridges. If you know that there are the processes that are taking place on the continents are also taking place in the ocean beds, you can easily understand, you can easily relate to these concepts then. Otherwise, what happens is that we'll start mucking up facts, but maybe we are not able to relate why and how. So to a great extent, this topic is part of geomorphology, right? In fact, you would find the last chapter towards the end of this book, Geomorphology by P. Dayal, you would find these topics mentioned there. Ocean bottom relief, ocean bottom topography is mentioned in that particular book of geomorphology. But the book that is given to you, Savindra Singh, will be good enough for this, or you can refer to either of the book. Then comes next aspect, temperature and salinity of oceans. Right? See, temperature and salinity of oceans. So if you know the factors that control temperature of atmosphere, to a great extent, you will also understand factors affecting temperature of oceans. Right? To a great extent, you are going to understand that. Right? I'm not saying completely, but then yes. Right? Salinity, obviously it is related to the oceans only. So this is how, and then you follow the next topic, that is heat and salt budget of oceans. I must tell you, this heat and salt budget of oceans, when it was incorporated in the syllabus, it gave goosebumps to most of the students. Right? Because it's not easily available in books. And when you start collecting information on internet, there's so much of material available, and they're all research based topics. Individual research is done on the salt budget of oceans or the heat budget of oceans. So it was a topic that troubled a lot of people, and UPSC probably knows this, so you should be ready with this topic. We will try to ease out the topic for you, heat and salt budget of oceans. right? Same thing, we also have a topic, a heat budget of atmosphere, right? So having said that, we need to comprehend these topics, right? Then we have ocean deposits, waves, currents, marine resources. Okay, coming to this current, although it is just one word, ocean current, but it has so much of interrelation. Like for example, when we talk about ocean currents, we also study oceans of currents of Pacific Ocean, Atlantic Ocean, Indian Ocean, probably the bulkiest topic of oceanography, bulkiest topic. So currents of all the three oceans, their impact on socio-economic life, their impact on vegetation and other aspects. Then we also have to understand El Nino and La Nina, Indian Ocean dipole, in the same topic. El Nino, if you study in Indian monsoon, obviously we give reference there. It's easier to understand El Nino when we are studying the currents of Pacific Ocean, because when you study the counter current, then you can easily relate to these phenomena. When you study the Somalian current in Indian Ocean, you will easily relate to the Indian Ocean dipole, whether it's positive, negative, what will be the effect, and so on. And also the pattern of the wind, planetary winds, direction of the planetary winds should be very clear to understand. For example, we should know that there is seasonality in monsoon, seasonality in Indian Peninsula, southwest monsoon, and therefore you will understand southwest current as well. You understand that winds are very strong in northeast monsoon, so you will understand northeast currents as well, right? You will understand why North Atlantic drift is from west to east, because if you know westerly direction, you will also understand the topic, right? So interrelations will be there. Then comes a very, very important topic for your exam, and that is going to be marine resources, mineral and energy resources. This will also be the part of your resources. There's a topic mentioned in your economic geography, and that is resources. Or in resources, what is important to relate is the ocean is the future resource. Now, how do you think about it? Whether it's food, from salt to fishing, it's important. From energy resources, rather the natural gas or the offshore oil wells, important. And also it is a source of future energy like tidal energy, right? So you need to understand ocean in detail, what is happening now, and you should also understand that how oceans will be useful, say 30 years from now, how oceans will support us as a future resource. So very interesting topic, very contemporary topic, right? The so-called that dynamic static topic, whatever you call it as, but I consider it's important. You should know every aspect of marine resources, right? Then we have topics like coral reefs, coral bleaching, and marine pollution. It is also the part of your environmental geography and also the part of your environment ecology, isn't it? General studies, right? Part of your general studies, including marine pollution. It's also the part of general studies. So to understand, if ocean is a resource and it's an open resource, there should be a law for extracting resources from sea, using it as for navigation, right? From defense to economic, the trade. It's very important aspect. So obviously this law of sea therefore becomes important for us. From the ancient times itself, the need for the law of sea was realized, right? And then we have these United Nations Convention of Law of Sea 3 times. So anyways, we'll see that in detail. So that is about oceanography, and which is important topic. If you ask me honestly, the topic isn't, and it's not a very bulky topic, so let us not discriminate. Let's prepare it on the whole. But the question on law of sea, important. This is another example where you relate. Let me take a point here, and this is the another topic where you can relate that static portion with the contemporary aspect. Like for example, the law of sea, if you see the conventions, if you see those principles of law of sea, static, okay, it's not going to change. How contemporary aspect, South China Sea issues, Strait of Hormuz issues, or what have we done for the increasing sea piracy in the coast of Somalia or the Red Sea region. How countries are have reacted to the law of sea. How many of them abide to the law of sea? Who are signatories to the law of sea? How many of them have ratified the law of sea? So this is what is the required aspect here. So anyways, let me come to the book, reference to the books here. Reference to the book, again, Physical Geography by Savinder Singh, which is useful. Right, all topics will be covered except the law of sea, so you can refer to the notes for that, right, for law of sea and application of it. So classes plus this book would be good enough to cover up the topic, right? We have so many books. Sharma and Wattle is one of them, and even Savinder Singh has a book on oceanography. D.S. Lal has written a book on oceanography. So it's all up to you whether you read them or not, all up to you, but I would suggest the Physical Geography Savinder Singh plus your class work would be good enough to handle questions in exam. Plus you should also be aware of the what is happening in the contemporary world, like marine pollution, what are the new laws for that, what are the changes, how South China Sea issue is important, or how other aspects are taking place globally. So that is what is required. Anyways, let's go to the next topic, and that is about biogeography. Biogeography. First topic is genesis of soil, classification and distribution of soil, soil profile, soil erosion, degradation and conservation. I'll be very honest here. When I read this soil, genesis of soil, classification of soil, distribution of soil, in the first reading I could not understand anything. Maybe my knowledge was very limited related to these pedology or changes in the soils or minerals present in the soils. So it was very difficult to relate to the concepts of soil and soil formation. And distribution becomes bulky, right? When you talk about the classification of soil, Marbert's classification, or this USDA classifications, then there's a lot of information here. So we have got no choice, right? We have to remember classification. But so far as the formation of soil is concerned, the genesis of soil is concerned, and the distribution is concerned, then I started relating it to the climatic condition, then I started relating it to the bit of geological information, the topics becomes easier. It's highly conceptual. Probably the way I approached initially, or probably the way it was written in the books, was very factual, like it was information. But then when you start relating to the conceptual aspect, how and why, then it is easier to understand and it becomes easy topic. One part that is important and you need to trouble your memory, you need to push your memory, and that would be classification of soils. Right? It's memory based. You need to memorize these. There is no no other way. But anyways, we are ready to memorize these things. And then we have distribution of soils, genesis of soils, right? Conceptually very strong. You can easily refer to that. Then very common topics like soil erosion, factors affecting distribution of plants and animals. Again, theoretical. It's purely theoretical. Very close to the biosciences, right? Biosciences. Then topics like problems of deforestation, agroforestry, social forestry, wildlife, major gene pool. It has a very limited source, in the sense that you don't find much of the material or much of the books which refer to the major gene pool or gene centers of the world, although we have a lot of sources for it, don't worry about it. But then the comfort level would be relatively lesser in these cases, in this particular topic. Rest is easy, also the part of your environmental geography, so you can also try to understand environmental geography here. I'll just collectively study that. See, when we talk about the these ecology, environment, right, influence of man on ecology, environment, or we talk about the environmental degradation, management, conservation, etc., right, soil, this soil erosion which is mentioned here will also be discussed in the environmental degradation, because it's a part of environmental degradation. Similarly, hazards, already we have discussed this topic like marine pollution in oceans. This will also be a part here. So these two topics put together, biogeography and this environmental geography, this will be also the part of your general studies, right? General studies. Optional to hai, it is optional as well, but majority of that would also be useful for your general studies. Ecological principles, right? We need to understand what are the ecological principles, like we need to understand what are the different aspects of ecology, different definitions of ecology, what are the different aspects that we need to focus upon. So I guess it should not be a major problem, right? It's a part of both, right? There is a book that I can refer here, right? That is Made Simple series, right? First volume by Rupa publication, and this particular book you should, right, focus on the selected chapters only, right? Selected chapters. So we'll be telling you what are the selected chapters here. Plus, obviously, when the syllabus demands, you should be thorough with the current events also. And here we have a topic in paper 2 which talks about contemporary issues. So there are many topics common in contemporary issues and environmental geography, right? So this summarizes the physical geography, including geomorphology, lithosphere, then climatology, the atmosphere, oceanography, the hydrosphere, and when all the three get together, then it's biosphere, so biogeography. Okay, let's move to the next topic. Then if you see your paper 1 section B, right, human aspect or human geography, there's a topic mentioned here called as perspectives in human geography. See, the perspectives in human geography is actually the geographical thought. Geographical thoughts. If I look at the syllabus and types of questions prior to 2009, there were topics like contributions of Greek geographers, Romans, later in the medieval times in the Arab geographers, which was called as classical phase. Then there were contributions from European geographers, primarily German geographers, then British geographers, then some topics of Russian geographers as well. And then there were philosophies like aerial differentiation and the topics which were mentioned. But the new syllabus talks only about the philosophical aspects. It talks only about the geographical thoughts, right? The outcome of that, as I said, the philosophical aspects of geography. Now, what do we study in this particular topic? Although these topics have not been mentioned, like the contributions from various geographers have not been mentioned here, but we cannot ignore them. To understand aerial differentiation and the reference to the other topics, we need to understand what were the contributions made by Greeks. How did geography evolve from mere description of Earth's surface to mathematical geography, to political geography, later to the environmental geography, and how did we study geography? So if I put it in this way, it is actually the evolution of geography as a subject, as a discipline. That is what is needed to be, focused here. So what were the different phases in geography? What were the changes in the methodology and technique of geography? And what are we doing now? How do we study geography? Whether it is a regional approach that we follow, whether it's a systematic approach that we follow. So there's a big question mark in geography. Is geography a discipline following the law-based study, or that means generalizations? Or is geography following the descriptive ways of research or study? So the topic is like areal differentiation, therefore. Focusing upon how one area is unique than others, focusing on uniqueness, and then we are talking regional geography, then dichotomies. What are the different dichotomies that have risen over a period of time? And there is one very important topic, like it's quantitative revolution, which is paradigm shift in geography. So it's very interesting, provided you should be able to relate to geography. In the sense, if I briefly discuss this particular topic over here, so from physical geography, there was time where the focus was more on the physical geography, and implicitly they were all, determinist in nature. When I say determinist, that means nature determines the course of human interaction. It's the natural conditions which shape human beings. That is, that was the belief. The Arabs, environmental determinists. Then there was later on, with the evolution of this French school of thoughts, Vidal de Lablache, or there was a thoughts change in the thought process, and the term comes possibilism. Right? That man can change his milieu, man can change his surrounding depending upon the evolution, cultural evolution. So, for example, if life was tough in Arabian Peninsula, it is very tough in Arabian Peninsula because the temperature is very high. It's a desert condition. But today we have huge construction going on there. There was evolution, or rather invention of air conditioning system, and it evolved over a period of time, and today we have one of the largest industrial base or construction going on in these areas. So man using his knowledge, man using his intellect could change his surrounding. And then there's League of Geographers who follow the determinism, and the League of Geographers which follow the possibilism. So that led to the growth of this dichotomy, or there could two phases of geographical thinking, focusing on the natural generalizations and focusing upon the what you call it as descriptions. But later, towards the 1960s and 70s, with the growth of this Club of Rome concepts, we would find that the humanizing aspect comes. Right? If we follow generalizations, we say 2 plus 2 is equal to 4. That means cause should always be same as that of effect. Rather, for the same cause, there should be same effect. Or reverse also, for the same effect, there should be same cause. But then the thought geographers started thinking that if for same effect there should be same cause, then let's take an example. Africa is tropical, so is Australia. Do they have the same level of development? No. Africa has, human development index is very poor there, but Australia has not. Likewise, it is not the natural conditions which determine the growth of human beings, or rather the development of human beings. There are many temperate countries in the world which have a poor human development index, and many same temperate regions, same temperate climatic conditions have a very high human development index. So there is something beyond that. So it is not that same effect has the same cause. So this gradually shifted the focus towards welfare geography. This shifted focus later on to the environmentalism, and 1980s onwards we have some great writings like Our Common Future, Rachel Carson's Silent Springs, right? The Club of Rome's limits to growth. So that led to the focus to the environmentalism, and today we talk about we are in the age of environmentalism. We are focusing upon environmentalism. So talking about the times when we are focused upon the extraction of resources, extraction of, focus more on the industrial growth and industrial revolution, and then the times of the social aspects of the the growth, like population is increasing, like new Malthusian eras, to the times when we are talking about environmentalism as the main theme of geography. So there has been a continuous evolution of geography that has taken place, and that is what is to be studied in here. Right? In one discussion, I can't summarize everything, but then just to give you an idea, and that is why our topic then becomes Human Development Index towards the last. Right? So from nature, natural conditions, how they shape up human beings, to the Human Development Index, how geography and the focus in geography has evolved over a period of time. It's very interesting, provided you should know how to study and what are the focuses. I would refer a book here, Perspectives of Human Geography, Sudipta Adhikari. Some of you might also take up Majid Sen's book, but that is also there, but Sudipta Adhikari would be excellent. There's another very good book by R.N. Dixit, you can also refer to that. My suggestion would be to go for Sudipta Adhikari. Right? So let's continue to the next topic, and then comes economic geography. So geographical thoughts, I hope you understood. It focuses on the philosophical aspects. See, if we talk about the geographical thoughts for a minute, this topic would be applied to all the topics, whether it's geomorphology, whether it's climatology, whether it's oceanography, or it's economic geography or social geography or political geography. Geographical thoughts can be asked in any topic relating to it. Right? So economic geography, let's say, I'll take an example of economic geography here as well. There's a topic here called as energy crisis and limits to growth. Now this limits to growth developed in 1972, it was basically an essay, right, that developed in the, in MIT in USA by Forrester and Meadows. The group was called as Club of Rome. Right? So our common future, that was the title of the essay, but I'll come to that later when we discuss economic geography. So as of now, I'm just giving an example how geographical thought is important. It has its influence in every topic. Every topic has a potential, like geographical thoughts can be connected to that topic. Okay. So what are the topics here? Measurement and problems, world resources and their distribution, right? Also the part of your general studies. Then we have world agriculture. So what are the major economic activities that we talk about? The primary industry, primary economic activities, secondary, tertiary. We also have two other economic activities like quinary and quaternary economic activities, but here we focus upon only these three of them: primary, secondary and tertiary. So primary industry, we know about its mining, agriculture and so on, which focuses more on the natural resources. So here first would be agriculture, topic is agriculture. The second is secondary economic activities, where industries etc. are focused, right? So then obviously the second aspect after this agriculture, industries and etc. would be world industry. Third is tertiary sector, and here we have these three aspects. So try to understand the focus, how syllabus would have evolved for economic geography. So three basic industry, economic activities. So agriculture is there, industry, we need to understand industry of the world. We need to focus upon trade, how trade has evolved over a period of time, where we discuss the role of WTO and so many others. Right? So this is how world economic geography, can be studied. And also relating to one more aspect. See, when we talk about geography, geography relates nature and man, isn't it? It's the natural influence on man and man's response to nature. The interrelationship is what is called as geography, right? And when we talk about the nature, this interrelationship, We also need to understand the social aspect, that is sometimes the lack of development of man or the means of development for man. So means of development in this particular topic we have already mentioned, like agriculture, industries, trade, or mining in mines. But why lack of development? What are the problems related to that, like food and nutrition problems of the world? Can you understand the syllabus? So on one end we are discussing the world agricultural aspect. What are the different types of agriculture studied, practiced across the globe? To the other side we are studying the problems like food and nutrition problems of the world. So what is the focus? Focus is what should we do in all these agricultural regions of the world to improve the food production and reduce the hunger and poverty, to reduce the nutrition problems. Similarly, when we talk about world industrial locational patterns, so we understand these are industries, this is the locational pattern of the industries. So what are the problems related to industries? How can we reduce the problems of industries? Same thing, what is the pattern of the world trade and how will it be useful, and how is it, what are the problems in world trade presently? So it goes without saying again, it is environmental aspect that is important here, right? Applied aspect that is important here. So this is how the economic geography should be emphasized, should be focused. Understanding the meaning of development, right? And then we understand what should we do, what steps can be taken to develop the world. So then we understand these topics. Then we have next aspect, next discussion on population and settlement. This is from paper 1, right? This is from paper 1. Growth and distribution of world population, demographic attributes, causes, consequences of migration, underpopulation, and so on, right? And population theories, world problems, policies, and so on. So these topics are basically about the human aspects, the distribution of humans, growth of humans, different theories, different philosophers which have suggested the growth over a period of time, right? How growth has occurred in population, what are the problems and possibly policies. So there are two poles of problems. When you look at the developed world like Europe, you find there's depopulation. Japan, depopulation. On the other hand, when you see the developing and less developed world, you will find overpopulation, very high birth rate, right? So how to balance this? What are the problems related to that, right? These days we talk about demographic dividend of India. How is it, how to be used, and so on. So we will be relating this population theories and policies and problems to Indian aspects. So we shall discuss these topics along with the paper 2, right? These are the topics mentioned in your paper 2. So here we talk about the population theories of world or population problems of world. Here we are talking about the population policies and problems of India. Growth and distribution of world population, and here we have the growth and distribution of Indian population. So these two will be studied simultaneously. Now we are talking about population as a social capital, which is one of the most important topic of this of population, and here we will discuss the demographic dividend in India and what are the prospects, right? Demographic dividend of India. So there is a relation between general studies, beg your pardon, there's a relation between paper 1 of optionals and paper 2 of optionals in this topic. So we will be simultaneously handling this topic. For this, one more topic I'll add, that is settlements, right? Settlements, which include topics like, here you can understand hierarchy of urban settlements, right, where we study different types of cities, urban morphology, primate city, rank size rule, right, classification of towns. And here in this condition we are going to, in paper 2 we are going to discuss morphology of Indian cities, functional classification of Indian towns. So both topics will be studied simultaneously, right? So there will be paper 1, settlement of paper 1 and settlement of paper 2. Similarly, your problems and remedies of urbanization, same thing here, you can see problems of urbanization and remedies. So topics would remain the same, right? The context will change. First is a very generalized concept, and then it would be the context to Indian conditions, right? Indian geography. So this is about population and settlement. See, so far as the books are concerned, one, we will refer to Human Geography, Majid Hussein's book, that is Models in Geography. Models in Geography. Right, it's a good book. Again, there's another book by Made Simple series, but it is volume 2. You should have both these books, right? But again, after NCERT's 12th standard, NCERT's of Human and Economic Geography, right? The reference book, if you want a reference book, there are so many other reference books, like you can also refer to R.C. Chandna for population. Beg your pardon. So R.C. Chandna's book for population. So there are few more books which we can refer, like R. Ramachandran for urbanization. But I would suggest these books, class notes should be good enough, plus you should be ready with the updation, right? Updation part should be there. When I say updation, like there are topics like slum problems, there are topics like problems of urbanization, there are topics like population problems. So you should be voracious reader to understand these topics, because they are also very useful in understanding general studies, in understanding rather you will get a lot of material for your essays as well, right? So far as the essay is concerned, there will be a lot of topics that you need to refer to, so that you can be very comfortable with the essay as well. Then let's go to the next discussion, next topic, and that is regional development and planning. See, this is a very, very essential part of geography. After all, when we talk about the civil services examination, the regional development and planning becomes very important, right? It becomes the part of your services, it becomes a part of your studies, it becomes a part of the application. So first would be about regional classification, that is, what is region? How do we define a region? So there's a functional region, there's a planning region, there are regions, physiographic regions. So there will be quantified method of regionalization, there are qualified methods of qualitative method of regionalization. So that is what we need to discuss. And there is a very interesting concept of growth center and growth pole over here, because these growth centers and growth poles were actually given to describe the industrial growth, how a region can develop an industrial region, and what are the elements of the growth. So we have some models over here, models such as core periphery model, then the Paroxene-Bordwell concept. And I'll tell you here, this concept was applied in the second 5-year plan in India. If you read your second 5-year plan, when we talk about heavy industrialization, setting up of heavy basic industries. Now, why basic industries? Because if we set up steel plants and we set up the primary industries, it will help, rather it provides the raw material for other industries to flourish. And there will be accumulation of growth, there will be accumulation of labor, there will be accumulation of investment, and when it reaches to the peak of it, there will be decentralization of growth. There will be trickling down effect of the growth. And necessarily these areas of present day Jharkhand, Chhattisgarh, Orissa was chosen because if government sets up the steel plant over there, it will also attract other industries, and the region becomes industrially developed because it has also other advantages like proximity to the ports like Paradeep, Haldia and Visakhapatnam. So the second 5-year plan had the implicit meaning of the growth pool. That is how you connect the concept. So the Mahalanobis model that we talk about has a theoretical background of the growth pole and growth center concept. Then we have plannings and environmental issues. Now I'll connect the paper 2 again here. This is the topic for paper 2, right? Regional development and planning. This is a general idea for paper 1, right? And this is for paper 2. Right, topics like integrated rural development programs, Panchayati Raj, decentralization, 5-year planning, and you know, these regional plans like backward area, desert prone, hill, tribal, multi-level planning. Now, these topics are essentially important for paper 2 and also very important for your journal studies, isn't it? There are a lot of social issues which are asked. There are a lot of planning we study in economy. Right, we study Panchayati Raj and decentralization in polity. So it's a very integrated topic. You have, when you develop a region, you should know the geographical conditions, you should know the political aspect, you should know the economic aspect, how should we proceed. Then you should also have the social aspect into it. So there's a complete package, you can say, of regional development and planning, which is very important for your exam, for your optionals. And I must tell you, the type of questions that are asked are very applied. So the sources, number 1 would be the book that we are going to refer for paper 2. For paper 2, that would be D.R. Kuller. That will be one reference book for paper 2 for your optionals. Plus, you would also refer to a lot of journals, magazines like Yojana and Kurukshetra. These magazines will provide you the case study. Like suppose there's an issue on watershed management program in Yojana, so it's very useful for us. You will get some case studies, you will get some examples over there. There are some examples, after all they are from Ministry of Planning and Development and Rural Development, so it's always useful, right? You go through that and keep taking note of current affairs as well, current aspect as well, as in what are the new policies that have been taken up for a particular region to develop, new programs which are started having a regional element, like the program started for Himalayan areas, the program started for desert areas, the program started related to irrigation, and you need to incorporate these programs, right? Here, when we talk about the micro irrigation in agriculture, the micro irrigation will also be the part of your this drought prone area program, also the part of the hill development. When we talk about the organic farming, so hilly areas can also be one of the regions of organic farming. So this is how you integrate your topics. This is how you bring in current affairs into your these regional development and planning topics. Then moving on to the next topic that is mentioned. So take out your paper 1. Last topic is models and theories in geography, that is model theories and laws in human geography. And I must tell you, by the time we reach over here, we would have completed all the topics. By the time we reach to this, we complete the regional development planning, we would have completed all the topics mentioned in the models and theories. It goes parallelly with all the topics of human geography. For example, in geographical thoughts, towards the end we study spatial, we study the systematic analysis. We study what are systems, how systems work, and the analysis, right? So it is system analysis of human geography from geographical thoughts, that is perspectives of human geography. Then Malthusian, Marxian and demographic transition model is the topic mentioned in the discussed in population geography. Right? Population geography. The central place theory and of Christoller and Losch, this is discussed in settlement. Right? The settlement geography. Perrox Bordwell, right? This concept is studied in regional development planning, RDP. Then and also Rostov's model of growth, sorry. This is also studied in regional development and planning. So first we focus on growth, how growth happens, and then we'll talk about development. Because the poor government cannot help poor. So first we must focus on the growth along with the development. It's not that they can be isolated, but at the same time growth is very necessary for development. Without growth, development is very difficult. So development ensures growth. The growth doesn't ensure development. Right? So on one side we study the growth, how growth can take place, and then next side, like other side, we study how growth percolates in the society, right, leads to development. The qualitative improvement, qualitative increment in the living standards, right? So that is how we focus. Then we have one more topic like Von Thunen model and agriculture location model. This we are going to study in economic geography. Weber's industrial location model, again in economic geography. So see, geographical thoughts covered: population geography, economic geography, settlement geography and regional development planning. So anyways, we are covering these topics along with it, so you need not to worry about this chapter 5th. It is anyways covered in the discussion of human geography. Let's come to the very important part, that is paper 2, physical setting of India, also important for general studies. So you must be aware of these topics like physiography of India, Indian climate. It's actually the application of paper 1 to the paper 2, where in the paper 1 we study the development or rather origin of fold mountains. In paper 1 we study the theories related to the formation of mountains, and in paper 2 we study the structural relief and study the formation of Himalayas. In paper 1 we study jet streams, monsoon, seasonal winds, El Nino. Here we study mechanism of seasonal winds in India, which is the Indian monsoon. Genesis of soil in paper 1. Here we focus upon Indian soils, right? What are the different types of Indian soils that we found in the relief chapter. Similarly, drainage pattern, tropical cyclones, western disturbances, floods and droughts, right? Climatic classification. For paper 2, there is one topic, one book, I'm repeating, D.R. Kuller, Indian Geography by D.R. Kuller. Coming to the next associated topic, next up you can discuss resources. See, in economic geography we have already covered, we already cover this resources topic, right? We cover up the topics like energy resources, mineral resources, water resources, and here it would be more India specific, right? Indian resources. Similarly, next topic, that is agriculture, right? Agriculture of India. In the agriculture of India, one very important and very current aspect related topic is this agricultural infrastructure, right? Fertilizers, seeds, power, institutional factors like land holdings, land tenure, land reforms. Now this is also the part of your economy, right? Indian economy, right? It's also the part of Indian economy, so very useful for general studies, paper 3 also. Apart from that, here it will be very current oriented. Current topics are included in here. Then cropping pattern, agricultural intensity, crop combination, these are all topics which are, you can say so, static, right? It doesn't change, but then Data is required to supplement your answers. Then we have green revolution, ecological impacts, dryland farming, all these topics which will be very dynamic, very much useful. I'm again referring to these magazines, Kurukshetra and Yojana, and also various articles that you need to collect from sources like the Hindu or Indian Express, related to agriculture, related to green revolution, new technologies in agriculture, irrigation, so on. These topics like agricultural, ecological regions, agroclimatic regions, these are very theoretical, very academic topics. So it's as theories have been given forward as it is. There's no dynamism as such involved in these topics. There will be static, right? The word static we know now. And then it's very academic. It's not required for general studies. Only for optionals we study such topics, right? So book will remain the same. D.R. Kuller, good enough. You want to read some books. There's so many books that I can refer otherwise also, but this one book will suffice the need. Apart from your current affairs. So then comes industries. Now, what is main point here? Locational factors of industries. Here, when we talk about locational factors, we generally refer to geographical factors. Other than geographical factors, also some political factors are also involved, so that we'll be focusing upon. Along with that, problems of industries. Like suppose, what are the geographical factors that support cotton industries and why are they located in the Gujarat-Maharashtra region? So from edaphic factors, that is soil factors, to climatic factors, to labor, to port facility, all that needs to be discussed. Then problems, erratic behavior of monsoon, and then how cotton production changes, what are the international aspects to it, what are the challenges that cotton industries face from the frequent deadlock that is trade unionism to the competition from synthetic fibers. These are topics that we need to emphasize. That is how we study this particular topic. Then we have topics which are very much related to the economy as well, like multinationals, liberalizations, special economic zones, and then tourism, like including ecotourism. And then we have this industrial regionalization. See, because we are studying geography, regionalization cannot be separated from the study of geography. So there will be agricultural regionalization, there will be climatic regionalization, industrial regionalizations, tribal regions. So regionalization, whenever we talk about regionalization, it means it's purely the geographical aspect that we need to focus upon. So we will divide India into major industrial regions, like we have 8 major industrial regions and then some minor industrial regions. So we'll see the category and why industries, what type of industries are there, like Kolkata Haldia, what type of industries are there other than the jute industries. And why so? What are the factors supporting them? Why Gujarat has become a major industrial zones of India, right? Owing to its number of minor ports, because of many inundations like bays and gulfs present in Gujarat coast and huge investment there. So these are factors that we need to emphasize upon. Then next point, next related topic, if there are industries, we also emphasize upon transportation, including railways, waterways, airways, pipelines, and this is a part of your infrastructure. Right? General Studies paper 3, if you look at these, this is the infrastructure part. Then how international trade is working, again related to economy, right? Indian space program, what is the space program, how important is the space program, what are the future endeavors of India in space programs. So here now you see the dynamism of the syllabus. One part we were studying about the geomorphology and climatology, and now we are reaching to the Indian space program, and these special economic zones or MNCs or trade policies. So a lot of people say there's a lot of vastness of the syllabus. It is not vast, right? In the sense that it doesn't have a huge syllabus, but it has many dimensions of the syllabus. There's a social concept here, there's an economic aspect covered here, there's science-based concepts here, there are philosophical-based concepts here, there are political geography involved in here. So when you see this entire, if you prepare for geography in detail, you will be also studying so many aspects of general studies, right? You will be very comfortable in many topics of general studies. That is why we choose the optional, which is not, most of you take optional, those you have not studied in college days, right? It is not the economic, your academic background that you follow in this particular, in choosing optional, right? We choose an optional other than our, the graduation, is because that has a lot of relevance with the general studies. So here there is an optional which has so much of relevance, right? And it is in front of you, right? You can see the syllabus. So choice is yours, the way you look at it, right? Problems are not the way they are. The problems are the way we look at them, and the incapability to find solutions for them. So the reason is, when you study so much of syllabus, you will also be incorporating, you will also be involving yourself into huge area of general studies. Then let me complete this. So then, as I was mentioning, political aspect. So you study geographical basis of Indian federalism here. You study, regional conscious and interstate issues. Then we also have to study the, emergence of new states and international boundaries and related issues. Geopolitics of South Asia and Indian Ocean, India's role in world affairs. So it will also incorporate international relations. Right? International relations, right, which is very dynamic. The questions which are asked, Act East policy was asked here. The only difference here would be that we need to add, when we write answers, geographical aspects should dominate here, right? Geographical aspects should be reflected in your answers. It should be there in your answers. Like when we refer in this geographical base of Indian federalism, so you should understand about diversity of India, talk about the physiographic features of India, talk about the climatic diversity of India, talk about the river resource diversity of India. So we will not be mentioning articles referring to the Indian federalism. We will be referring to the geographical aspect which necessitate the kind of federalism that we have, right? We will also be reflecting towards the end as the unity in diversity, the interdependence that we have, right? The interdependence that we have considering the diverse regions, right? So this is where we need to emphasize. Okay, let me complete this last topic, and this is contemporary issues. It's nothing but the current affairs aspect. Look at the topics, right? We would have covered most of the topics by now, but then still, like landslides, earthquakes, tsunamis, floods, droughts, right, environmental pollutions, all this is the part of your disaster management as well, right? It's also the part of your disaster management, isn't it? Then changes in environmental aspect. From here, if you consider environmental degradation, deforestation, desertification, soil problems of this, all this particular topic will be the part of your environment ecology, right? And then again, geographical aspect, it is I would write it as miscellaneous, right? It has a topics like from economy, like globalization and Indian economy, environmental awareness from ecology, then problems of agrarian unrest. So a wide range of topics that are included in the contemporary issues. So all depends upon you, how do you look at the problems, all depends upon you, how do you handle this topic. So if you successfully are done with the geography syllabus, a lot of your general studies will be covered. So it doesn't matter even if it is vast. Well, although I don't say that it is vast. Vastness of the syllabus is within the limits of general studies. All the dimensions are parallel to the general studies, right? So it all depends upon you how to handle that. So we will be trying to simplify all these topics. We'll be trying to simplify how geography is looked upon, and we will also help you with whatever material is required, focusing on from answer writing to your conceptual clarity. Right? Thanks for this, and let us start the geography classes. Hello everyone, so welcome to the class of geography. Here we are going to discuss about the very first topic that is mentioned in the syllabus, and first topic that is very important to understand geography, and it is about origin of Earth, right, and evolution of Earth's crust. So here we are going to have a discussion on what has been the viewpoints about the origin of Earth. Various geographers who have presented their concept, who have presented their theories on the explanation about the origin of Earth, right? And see, probably it is the first question that man would have asked himself, right? With the rise in the consciousness, the first question obviously comes: who created the universe? Who created Earth? Who created everything that we see around us? There are mythological theories, there are scientific theories, there are beliefs, there are religious aspects associated with it, because it's, after all, we are talking about the origin of the first point, like origin about the Earth or the universe for that matter. So it's nothing less than God, right? We are talking about who has created all this. So there are various viewpoints. There can be a scientific aspect to it, and also the mythological aspect to it, right? Mythological aspect to it, some religious aspects to it. So obviously we will not be going to the mythological aspect. We will be focusing to what is the scientific aspect of the origin of Earth, how geographers have described it. So far as this aspect is concerned, there are two viewpoints here. One says the unilateral or one point origin of Earth, right? Or the origin has happened from singularity. So they believe in singularity, that a single particle existed, and because of the single particles the universe has been created. There are other aspects which is, can you say, bilateral, or some of them are multilateral aspects, which believe that there have been more than one star or more than one entity that led to the origin of Earth. So we usually call them as binary star hypothesis or binary star hypothesis, which believe that the origin of universe has taken place because of multiple factors or multiple initial points. It's not only one star, but there were probably two or more than two stars. We are having a discussion exactly on this, and how geographers, rather how theories have evolved from the times of Immanuel Kant, or Kantian hypothesis, of which was called as gaseous hypothesis, to the Big Bang explosion, right? That is our main point. So let us discuss theories one by one. First theory is gaseous hypothesis by Kant. Gaseous hypothesis by Kant. See, he used two principles to explain this hypothesis. First is the concept of gravitation. Obviously which he borrowed from the Newtonian explanation. Second concept is about the angular momentum. Of Earth. So the very first aspect, gravitation, that is attraction of particles. Everyone believed, there are some common beliefs, that there was one thing or one particle or maybe multi-particles present in the space. They were called as nebulas. Right? They were called as nebulas. Right? We are not referring to Higgs boson, God's particle, but at least something of that sort. A particle that existed in the past, which was the creator of this entire universe. There were multiple, as per the gaseous hypothesis of Kant, says there were few particles present in universe. Let's say these particles present in universe which were scattered. Right? They were scattered. And because there is a mutual attraction, right? Mutual attraction. And when we say mutual attraction, we actually mean the force of gravity existed between these particles. Right? So all these particles started attracting each other. Right? So he brings in the concept of gravitation. So particles attracting each other led to some kind of movement present in these. So initially the particle was cold. As per he has not said it was very hot or something. They were cold particles moving along each other, moving with respect to each other, around each other, because of the gravitational pull. So due to gravitation, they did not merge with each other, rather started encircling each other. That mutual attraction led to some kind of rotatory effect on each other and started rotating. So if you look at the diagram here, in this case, there are some particles suspended. They start attracting with each other, and as a result of the attraction, there was some kind of rotatory movement, some kind of rotation. And what was the cause of this rotation? Kant says it is gravitational pull. That is the main cause of attraction. So as attraction happened, these particles started coming close to each other. Right? Particles came close to each other. The angular momentum started increasing. With the increase, with coming closer, the angular momentum increased. So the rotation speed therefore started increasing. So when we talk about angular momentum, right, not a physics class here, but just an idea, angular momentum is dependent upon the speed. Basically we talk about the speed. It is dependent upon the mass. So ignore mass as if now we are just focusing upon the speed. So the conservation of angular momentum says, if the speed reduces, if the distance reduces, if the radius reduces, to maintain the angular momentum, the rotation velocity will start increasing. So they started coming close to each other, and as they started coming close, there was increase in rotation velocity of it. Right? So the rotational velocity started increasing. So more and more inward movement, the spin starts getting faster. It's like, I'm sure most of you would have read in your physics class that if you keep your doll or any rotating object in hands like this wide open, so the rotation velocity will be higher. But if the hands are folded, the rotation speed will further increase. Right? Rotation velocity will further increase. Why? Because as the r reduces, as the distance reduces, to conserve momentum, the spin will be higher. Right? I'm sure you must have read about this omega r. So if the r reduces, obviously the rotation velocity will increase. So exactly in the same manner, what happened was they were scattered away from each other, but due to mutual attraction they started coming closer and started rotating. As they continue to attract each other, the radius will reduce, the distance will reduce, right, between each other. To conserve the momentum or the angular momentum, what will happen is the rotation speed will start increasing. Now that is the point here. So please emphasize, now pay attention here. Let's say the next aspect of this gaseous hypothesis. So what we have said so far, that angular momentum remains conserved, as we all know, right? Because the distance started reducing, distance reduced, this started faster rotation. So rotation velocity increased. Rotation velocity increased. Okay, now if the rotation velocity increases, Kant says that the centrifugal force will also start increasing. Right? Must have been known about the centrifugal force, the force which sends rotating objects outwards away from the center. Imagine a juicer or a grinder. Right? You rotate it a step 1, suppose. So it will start spinning. The juice or anything that is getting grinded will be thrown to some extent, thrown to a certain distance, that is centrifugal. But you take it to the step 2, it will throw faster. Step 3, it will spill over everywhere. So as the speed is increasing, the matter that is rotating will also be pushed outwards. So the increase in the rotation velocity also increased the centrifugal force. Also increased the centrifugal force. Understood the point? So as they started spinning, the centrifugal force increased. And there was a time when the centrifugal force, now in this particular diagram, in this particular picture, can you see this rotation? Right? It's continuously rotating. And now because the centrifugal force is applied, you can see that rings started separating. Because there will be a time, there will be a point where the rotation effect, or the centrifugal effect rather, will exceed the gravitational pull. Right? Because it's spinning at a greater speed. I'm just taking an example of a grinder or a juicer. You keep moving faster, it will spill things away from each other, right? Or at a greater distance, because that rotation will also have the centrifugal effect. So, right, with a further increase in centrifugal force, as the centrifugal force exceeded, remember, centrifugal force exceeded the gravitational force, right, rings started separating, right? These rings started separating one by one, and that led to the development of these planets. Initially, as per Kant, they were all gases because why did the speed increase? Is because the friction in the gaseous particles increased the heat, right? When the particles start moving, obviously there will be a lot of friction, and that friction will increase heat. So when you heat a particle, when you heat a gaseous particle, it will start moving with a greater speed, right? So the continuous friction had the counter effect on the speed. It started further increasing, and the heat was so much that every particle was in gaseous form. That's why the term is gaseous hypothesis. So due to the centrifugal force, as they went away from each other, these gases condensed and solidified. So those gases which were lighter, away from the sun, away from the central point, right, away from the central aspect or central point, they are gaseous planets, and those which had relatively higher density were closer. So there are rocky planets, which are inner planets, and outer planets are gaseous planets. So rocky planets and gaseous planets. Why? Because all these gases which had lesser density were thrown away from the central point, were thrown away from the surface, and as a result of which, less density, as a result of which they started cooling down and later on condensed. Whereas those rock particles which had a higher density were not thrown for a greater distance, they were closer to the sun, which is today's sun or proto-sun of that time. So that was how origin of Earth has taken place according to, or origin of universe has taken place according to Kant. Now try to understand the drawbacks. Try to understand the problems here. First, what created the nebula? Right? What created the nebula? No answer for this. Right? What caused attraction? What caused attraction? So we don't have answers for this. So what were those forces which led to the attraction of particles? Right? There is no particular answer for this, right? Given by Kant or this hypothesis. And the question is, they started attracting, right? They started attracting, but at the same time, what kept them separate? Right? Them separate. So these smaller particles, they started moving by the attraction, but what was separating these particles earlier? This has not been said, and the basic question is, what created nebula? This was not very well explained by Kant, and he also exaggerated the force of centrifugal, etc. And also the conservation of law of momentum says the mass is also important. Right? So mass kept on increasing. He did not mention about the mass. Right? Or when the gaseous form, can this rotation effect be so strong on the gases? There were some drawbacks of Kantian hypothesis. Right? So next is nebular hypothesis. The nebular hypothesis was actually presented by Laplace he did one smart thing, but which was later on criticized. Although he actually discarded one problem about nebula. He said, rather he started his theory with a hot rotating gaseous matter. A hot rotating gaseous matter. Right? That is how he began the theory with Laplace. Because it was said that Kant said that there was friction and then heating and etc. etc. Then he says that there was a hot rotating gaseous matter which was called as nebula. Right? So nebula, as per Laplace, was hot, rotating, and what led to this entire thing is decrease in temperature. Decrease in temperature. So the nebula that was hot and rotating lost the temperature due to decrease in temperature. Right? Due to decrease in temperature, there was contraction. Right? There was contraction in this entire nebula. And due to contraction, right, this contraction, what will happen? Just now we discussed what will happen to a rotating surface if it contracts. The speed increases, right? The rotational velocity therefore increased. See, again, it's something like what Kant said. Kant also said the same thing, but he did not start with the hot gaseous matter. He said that there were nebula which started attracting, and because of collision, heat increased. Here he starts from there only and says that the contraction in nebula led to the increase in the velocity, right, of this rotating nebula. And I will just give you an example that as per the rotation velocity is concerned, if a rotating surface has a greater radius, then the speed is lesser. But if you keep reducing the radius, obviously the speed will keep on increasing. So then at this time, centrifugal force, right, the centrifugal force increased. Centrifugal force increased, right? Obviously that will also start acting if the rotation speed is higher. And when centrifugal force, right, centrifugal force is equal to this force of gravity or attraction, the matter floats. And due to increase in the gravitational force, there was a bulge created, right? A bulge was created. So this entire matter that is rotating, here, right, that was rotating, started separating one by one, again because the centrifugal force exceeded the force of attraction, that is gravitational force. So as it started, first ring was separated, right? Ring was separated containing 9 planets. And that is how solar system has come into existence as per Laplace. I am repeating again, it is not it's a modification over gaseous hypothesis. Right? It's not a theory that Laplace generated, it's more of a modification of the hypothesis. So therefore, if you look at the drawbacks of the theory, what are the drawbacks of this theory? First drawback, right? Origin of nebula, right? Origin of a nebula is a mystery, isn't it? Origin of a nebula is mystery. Who created nebula? Not clear by the theory. And why was it hot? Nothing has been clear. Then second aspect, he completely ignores the tilt of planets, right? The tilt of planets, right? Every planet has a tilt, axial tilt. What created that tilt, right? And same process, he says, that repeated, and that has led to the formation of satellites also, which is very difficult to believe in. So the question is that there was not much of a difference between the Laplacian concept and the Kantian hypothesis. So this is the gaseous hypothesis, right? So if you can compare gaseous hypothesis with other hypotheses, other theories, which we are going to discuss now onwards. So we have one more theory, right? Let's see the next point, next theory here, and that is the planetesimal theory. Okay, now we have concept, planetesimal hypothesis. Chamberlain, right? Chamberlain had given this concept of planetesimal hypothesis, right? What are planetesimal bodies? These are small particles, which can act as nuclei for planets. So you can remember that planet generating nuclei called as planetesimal bodies. So unlike the previous theories, planetesimal hypothesis says that there were dualistic viewpoints. It believes in dualistic origin of universe. Dualistic origin. So far we are talking about monistic. There was one sun, and which led to the development of other. He said there were two stars. One was the sun, present day sun, which is called as proto-sun. Another was, another point was the companion star. The companion star. So the first one was proto-sun. Second was the companion star. Companion star was bigger than sun. Was bigger than sun. And when we talk about the proto-sun, it is believed that it was relatively smaller and was cold matter. It probably did not have that much of heat that it has today. So the companion star passed next to the sun, proto-sun, which was cold, right? Passed next to sun, and therefore, right, because it passed next to sun, caused attraction, right, gravitational attraction on proto-sun, from where small particles separated. Small particles separated. Now these particles were called as planetesimal particles, right? Planetesimal particles, as I said, which will attract as nuclei for other particles. So number one, so this is suppose a companion star when it passed next to the sun. From the outer part of the sun, these particles separated, right? So obviously they will not be of the same size, right? They will not be of the same size. So relatively larger particles attracted smaller particles. Billions and billions of small particles were separated, right? Billions of small particles were separated. So the bigger particles started attracting smaller particles and assembled around this one star, nuclei, and which solidified, which got relatively tougher to form present day planet. So this is how planets were formed. So present day planet formation was because of the same reason, that there is a small particle attracting, right, because due to gravity, and gradually these particles started enlarging and forms, right? He also explained that these particles which could not get attracted, they had the mutual attraction and led to the formation of satellites. So primarily the matter is here that it is all the, all these smaller particles which detached from the sun, from the proto-sun, led to the formation of the entire solar system, entire universe. And why did it happen? Is because of this companion star. Okay, one more point, what is very interesting. He said that as the detachment started, as the movement of these particles started, this or attraction happened, this increased the violent tendency. When I say violent tendency in sun, that means there were some explosions, right? So explosions took place within the sun. All right, explosions started taking place. Why? Because there was attraction and probably some friction, etc., increase in the sun, and that led to the formation of explosiveness in. So the temperature of the sun started increasing. All this has done by the protostar. Beg your pardon. All this has been done by the companion star, which is a questionable point, obviously, which is the questionable point because of the fact that it is getting attracted by one star, obviously a bigger star, and then everything is changing because of this factor. So we are not considering, the rotation, we are not considering the attraction, nothing, no gaseous hypothesis, etc. in the region. And can satellites be formed by the mere aggregation of these planetesimal particles? This is a question. So if you compare the two theories, two hypotheses about the gaseous hypothesis, whether it's Laplace or the or the Kantian hypothesis, nebular hypothesis or planetesimal hypothesis, see, the nebular hypothesis believes in the monistic origin of universe, whereas the planetesimal believes in the dualistic origin, right? Dualistic origin of universe. So that is one of the main point of difference between the two. It believes that everything was in the gaseous form, whereas this believes, planetesimal hypothesis believes that it was in, right, it was proto-sun, right, sun, or which was called as proto-sun, from where the companion star had moved. So it is not the gaseous aspect. It takes into consideration the centrifugal effect and rotational velocity, whereas this particular hypothesis just believes in the attraction or gravitation. It does not talk about centrifugal effect, right? It does not talk about any centrifugal effect whatsoever, right? When you talk about nebula, it believes in that there was hot origin of universe, whereas it says that there was a cold mass that is or matter that was proto-sun, right? Proto-sun. So these are points of dissimilarities between the two viewpoints, the nebular hypothesis and the planetesimal hypothesis, right? So that is the main point of difference between these two, right? So next theory, which is the binary star hypothesis, it was presented by Russell, which is quite similar to what is the previous theory about the origin of Earth. According to this concept, there were actually three stars. One is the proto-sun, right? Proto-sun, and there were in fact two companion stars. So it is not the the theory that was presented similarly by the previous geographer. Here we talk about the second concept, that we have companion stars, which were companion star, and one more star which was called as intruding star, right? Called as intruding star. Now, as the intruding star came closer to these binary stars, the companion star was expanded or attracted by the intrusion of this new star. So in the previous theory, it was said that there were two stars, one was a proto-sun and the companion star. Here we are talking about one star, that is the proto-sun, and the companion star was attracted by the intruding star, the third star. So it's not actually binary as such. Three stars, one was the sun, one was the companion star, and a third one was the intruding star. So this intruding star actually had a gravitational pull, and because of the gravitational pull, right, the matter was extracted, right, matter was pulled out of the, companion star. So this is how the matter goes on. So he did not believe in the existence of two stars, rather he said the two stars existed, but the third star has led to the changes in universe, right, which was just a modification over the previous one. Then comes the very famous interstellar dust hypothesis. This hypothesis was actually mentioned by Schmidt. Otto Schmidt. Now, according to Schmidt, there are some interstellar dust. Even today, we can see that interstellar dust. What is that? Is the dust coming out of stars, right? Even today there is the breakdown of stars. So dust coming out of the stars due to the breakdown of stars. So a lot of that matter that is separated from the star is called as interstellar dust, right? And because the temperature is high, so it has more dust as well as gaseous particles, dust as well as gaseous particles. And that dust and gaseous particles which are separated away, which are separated, was the reason of because of the massive explosions that go on within the star. And he believes that even when we talk about the interstellar, the universe is full of these interstellar dust. Right, huge amount of interstellar dust can be seen in universe. Even today, there are a lot of meteoric dust particles that can be seen on Earth, which has been collected over a period of time. So this dust particles, this is basically those interstellar dust. Now, due to the gravitational pull of sun, it attracted interstellar dust towards itself. Right? This interstellar dust was attracted by the sun. Right? I'm repeating. I hope it is clear to all of you what is that interstellar dust. Right? The dust particles collected, the matter that is collected because of explosion in the stars because of various energy generation like collision, what you call it as the nuclear collision that takes place there, nuclear fusion that takes place in stars. And that dust particles scattered over was attracted by the sun. Right? So suppose this is sun at the center and dust particles assembled around sun. So there are two types of matter in this case. The dust particles and waves. Right? And both of them behave in different manner, have different tendencies. Right? Here there can be waves here refer to gases primarily. So this attraction within the dust particles is non-elastic. Right? Is non-elastic. Whereas in gaseous, attraction is elastic. Right? So the collision of particles, as all of them are attracted by sun, so all of them are moving towards the sun. So collision, it can be non-elastic and elastic. So gaseous have the elastic collision, whereas dust particles have non-elastic collision. They don't repel each other, they get fused with each other. So the dust particles moving towards sun, right? The dust particles which were moving towards sun can be, as per the Schmidt, can be still seen. The meteoric dust can still be seen, which is destroyed by the heat of sun. Primarily the temperature of sun destroys these dust particles. But the matter which was moving towards sun started increasing in size. And these small matter acted as embryos, small embryos for planets. These small embryos started attracting more and more of matter, right? More and more of matter was attracted and gradually took the shape, right? Took the shape of present day planets. So it is basically what he wanted to convey here is that dust particle, interstellar dust hypothesis says that the dust particles of the sun of the various stars get assembled together, and they were attracted by their stars. And here we are talking about solar system. It is the sun. So get attracted by the solar system, by the sun, due to its gravitational pull. So gradually they start getting together and together, and small embryo-like structures were formed. These acted as embryos of planets, which attracted further matter and enlarged in size to form planets. These gaseous particles condensed, right? Because obviously the temperature will be lesser, they cannot be attracted close to the sun, they remain away from the sun, little away from the sun, condensed, and leading to the formation of gaseous planets in the outer region. So those planets, those embryo-like structures that we are referring to, matter which was assembled together, led to the formation of these planets around sun, rocky planets around sun, whereas outside this, the gaseous particles which had elastic collision condensed to form gaseous planets which are away from the sun. This was interstellar dust hypothesis. And now we move to the theory that we believe in today. With the diagram itself, you should be able to understand. See, many geographers, many scientists, many research scholars have contributed to this theory. And the theory talks about singularity. What is meant by singularity? They said that there existed one matter which was so dense, right? Unimaginably dense. Right? And obviously that was because there was lot of attraction of particles towards this singularity. Because if it is dense, that means there's huge amount of mass present here. Like they say, the nucleus of the atom has huge amount of density, right? Even the light cannot pass through that. It is that dense, right? Because entire mass lies there in the nucleus, right? Only neutrons and protons which contain mass of the atom lies in the nucleus. So it is something like that. Unimaginably dense particle existed at the many billions years back. But what happened was that this singularity was so much, the density increased to an extent that it led to the explosion. Right? Density was so high that it led to an explosion. The matter was condensed to such an extent that there was intense explosion, right? Which called as Big Bang, and that happened around 13 to 14 billion years back. This massive explosion that took place. And the underlying principle of this entire Big Bang theory is Hubble's principle. What did he say? That the universe is expanding. Right? Said universe is expanding. So there are many laws, Hubble's laws, etc. So it is happening somewhat like this. There was a Big Bang, and then particles started moving. Now when we talk about this particular point here, it is that singularity, that one particle that existed, that had immense pressure, and probably temperature later. So pressure was so high, the density was so high that it started moving away. There was an explosion and the particles started moving away from each other. That's singularity to universe. They started moving away from each other. And the continuous expansion in this point, if you can imagine what would have happened, say 10 billion, what would have been there at 10 billion years back, or 12 billion years back. So all the dust particles, all these massive matter scattered, huge amount of matter scattered there. Even the light would not have been passed there. If we were there at the earth at that point of time, it would have been all dark. Because even the sun rays could not pass. There was so much of matter suspended here. Right? But then it started expanding. And expansion, it's like a huge balloon. Right? If you keep blowing air here, it will keep on expanding. Right? It will keep on getting bigger and bigger. And when it was very small, what will happen is that the particles would have been placed near to each other. These small dots that I'm drawing were close to each other. But as it started expanding, there was space created between these particles. There was an empty space created between these particles, isn't it? So now, right? So particles. So gradually the universe started becoming transparent. Right? The universe started becoming transparent. So it is said that around somewhere around 4 to 6 billion years back, the universe started getting transparent. It wasn't transparent at this point of time. It wasn't that transparent. So the transparency started increasing between the within the universe. As a simple experiment, say a simple example, that the balloon keeps on expanding and the particles start getting away from each other, creating space for light to enter, creating space for other matter to exist. Right? So this is what was the primary aspect. Then moving from this Big Bang aspect or the continuous expansion of universe, the temperature of universe decreased to about 4100 Kelvin. Right? Due to decrease in this temperature, right? Temperature decrease, it is believed to around 4100 Kelvin. Due to decrease in temperature, all these gaseous particles, all this matter started condensing. All these particles started condensing, which led to the solidification of matter. And that is how these small matter was converted into planets, and the space was created in between them. There was an empty region created between them. Right? That is what Big Bang theory explains, right? Related to the origin of Earth. Now, so far as exam is concerned, let us come to the exam. We don't expect question related to the origin of Earth. You check out previous question papers, there is no question asked on the origin of Earth. Because you see Laplace theory, binary star theory or gaseous hypothesis, they are redundant theory. They are almost rejected now. They don't have that much of acceptance presently. It is the Big Bang theory that we are focusing upon. So you have to understand the origin of Earth, basic idea about the origin of Earth, which is the first question, as I said, first question. Who created universe and what created Earth? So who created universe is still a mystery, is still a question, right? We can't answer that question just like that. But yes, what have been the theories? What have been the hypotheses so far? We are just focusing upon that. And having said that, you just go through right? Remember these theories one by one, and just for your understanding this topic we have discussed. Otherwise, I don't see this question important for exam. I have not seen any question that has been asked related to the origin of Earth. Right? So all these theories believe in some catastrophic explosion. Believe in there was a massive explosion. So all of them are somewhere believing the catastrophic explosion that has happened, that formed the universe, and later the temperature kept on reducing, which condensed this matter, because with a decrease in temperature there will be mutual attraction, the collision will happen, and then collision of particles led to the formation of these massive planets or satellites or so on. That is the first aspect related to the origin of Earth, right? Very brief idea. So I don't see the possibility to be asked in exam, but yes, it's important because it's mentioned in your syllabus. Anyways, you should understand what is how Earth has originated. Then let's come to the aspect of geomorphology. See, we divide landforms in many categories. One such category is the first order landform. As the map itself shows here, these are landforms of continental scale. These are landforms of continental scale. The entire, when I treat the entire Earth, it's landform, first order landform. Like suppose I take North America, right? North America, or I take South America or Pacific Ocean. These are the landforms which have been there on the surface of Earth at the time of origin and which has got modified over a period of time. So all the landforms, all the reference that we make for a continental scale is called as first order landforms, like Indian continent, North American continent, Pacific Ocean, and so on. So let us view Earth from satellites, right? Resolve this image up to say 12, 13, 14 kilometers above the surface, not even 12, 13 kilometers, somewhere around 100 kilometers from the surface. So you would see the entire North America, you would see many other areas. Now we zoom in to one feature on North America, or in South America or Asia or India, anywhere. Like suppose we focus on Himalayas, or we focus on Rocky Mountains. This is called as the second order landform. The entire Himalayas that I am focusing upon. I am focusing upon the entire range. So ranges, features of huge scale ranges. Now these are actually outcome of endogenetic forces. Endogenetic forces. What is meant by endogenetic forces? Those forces which originate below the surface of Earth. Like, now there are huge amount of heat that is generated below the surface of Earth, convective currents, which will be describing. One part of geomorphology will deal with the forces, that endogenetic forces only. The entire discussion will be based on endogenetic forces. So all the features, all the landforms which have been formed because of endogenic forces and plate movement are referred as the second order landforms. Rift valleys, second order landforms, right? Old fold mountains, plains which are of great extent. So we are zooming it to a particular feature. So we have 5 physiographic division of India. So that's a second order landform. Peninsular Plateau, Western Ghats, or Aravalis, or Himalayas, or Northern Plains. We talk about second order landform. But when I am referring to Indian peninsula, in Indian continent, subcontinent, that means first order landform. Then let us zoom it further, right? Let us zoom it further to some peak in Himalayas. Let's say Mount Everest, let's say some feature, like suppose a feature like this. We are focusing on a peak, right? This is the third order landform. Now, what we focus on the peak, what are we going to have discussion here? If I choose this peak to study, I will be seeing the slope of this peak, isn't it? What is the slope of this mountain peak? We'll focus why is it pointed, why is it so sharp, what do we call that? For example, this call is errate, right? So all the landforms which have been an outcome of exogenetic forces, that is erosive forces, they're called as third order landforms. These are third order landforms, like errate, like peak, and so on. So discuss this point. Now we are discussing this particular point to third order landform. So your geomorphology will take you to all these three features, right? Geomorphology will take you to the three different levels. In the very first discussion, we talk about the continental drift, how continents have evolved over a period of time. Right, we talk about the surface of Earth, what has been the evolution of surface of Earth. So when we talk about this landforms, rather the first order landform, let me go back, this first order landform. So we'll talk about this African plate, or this is an Asian plate, or this is a mid-Atlantic ridge. So here in this particular example, in this particular diagram or the discussion, it's about the entire Earth, how Pangea was formed, how Pangea splitted. Understood the point? The broader aspect. In the second level of geomorphology, we are going to have discussion on the second order landform. How mountains were formed, how volcanoes were formed. So what has evolution of Earth's crust done to the features that we see? And then in third aspect, we will be discussing the forces of exogenetic forces, or what we call it as erosive forces. Landforms which are outcome, which have been shaped rather by the exogenetic forces or erosive forces. How have these landforms developed? Why this sharpness? Why the slope is more? Why slope is less? So that will be the third aspect of geomorphology. And the philosophical background, like some models of landform evolution, which is conceptually very strong. Right? This is about the basic idea about the origin of Earth and evolution of landforms. Here onwards, we will be discussing the geological time scale and the interiors of Earth. Right? Thank you.